You may please extend the, yeah, fine, Krish. Okay. I ask Krish or Gagan, you may please extend the courtesy. Let's record as I want recording of my lectures. India. And Krish, to your question answer being as and when it falls, we'll take a call. Correct, yeah?
Okay, sir.
Okay. So let's get started with the topic for the day, and that being atoms and molecules. Correct, yeah?
So what about work, power, and energy?
Nothing about work by energy. Work by energy is still into very much foray. We are finding time out to get other topics also done. Pari passo, correct? Yeah. It's not
Okay,
that
sir.
a topic started, that topic will see the end and then only we can start with other topic, correct?
Okay, sir.
That may happen when you are dealing with one subject. Here you are dealing with three subjects. So we can move pari passo, right?
Okay, sir.
Okay. So we are in work by energy when it's related to physics, and we are 25 to 27% through it, as you know. But we are to see the next 73% of it later. Fine, yeah?
Okay, sir.
Okay. Yes, Krish, tell me, when we discovered atom, right, Krish?
Yes, sir.
Then we were of the opinion that atom is indivisible, correct? Repeat here, yes or no?
Yes, sir.
We were of the opinion back then, not now. Now we know. In fact, when the book was written, then also was known to the science diaspora. I'm relating to the time when we first did discover anything related to atom. Correct, Krish?
Yes, sir.
So we said, as the name suggests, it is something which cannot be divided further. It is indivisible, correct?
Yes, sir.
And whose principle was it? Can you name the scientist quickly?
John Dalton.
Scientist?
Dalton.
Dalton. So Dalton was of the opinion that atoms cannot be divided further, correct? Yeah?
Yes, sir.
But with advent of time, Gagan, with advent of time, there was improvisation in the theory, correct?
Yes, sir.
With advent of time, we did improvise and we got to know that atoms are very much divisible, right? Yeah.
Yes, sir.
And then we got to know, as per the advent of time, you say, or advancement in science, whichever way you look at it, we got to know, yes, atoms can be divided, and we are known to nucleus of an atom. We are now even known to nucleons or neutron and proton that an atom can comprise of. Of course, electron being the part. The other which we are known to is what we are trying to get a detailing on. Correct, yeah?
Yes, sir.
After of the Dalton fiasco, you say, or you say after of the Dalton, let us not berate it. Let us say that not fiasco, after of the Dalton improvisation. Now, if we are into improvising our theory, we got to know that atoms are divisible, and now we wanted to know, after of knowing that atoms are divisible, we were interested in knowing that what are the constituents of an atom, right? Yeah.
Yes, sir.
What we need to know, is an atom divisible or not? And if we are known to yes, an atom is divisible, then it goes without saying the next step will be to look for the constituents of an atom, right?
Yes, sir.
Okay, so this did catch interest of scientists. This theory did catch interest of scientists of that era, and they came up with few experimentation. They came up with few experimentation. They came up with few figment of imagination, and accordingly they had their models. Is it okay? They
Yes, sir.
came up with experimentation. Few came up just with figment of imagination. but everyone had something to say back then. Clear, dear? And why so? Because still we were novice, we were naive to what an atom comprises of. Correct, yeah?
Yes, sir.
So what happened, Krish? What happened, Gunika? That the first scientist who came up with a model was named J.J. Thomson. Correct, yeah?
Yes, sir.
Thomson being the first person in a way you can say, we are not privy to that around, so I won't be able to comment much on it. But certainly many a scientists who are drawn towards, and one of the scientists which had something to speak about a model as it caught his interest, that particular time what we had more propped up being what is inside of an atom, and it caught interest of a person known J.J. Thomson. And J.J. Thomson came with his model. His model of what? J.J. Thomson came with his model. His model of what? Anyone? His model of what an atom will comprise of. Claudia?
Yes, sir.
What did Thomson say? Krish, what did Thomson say? Or Gunika, what did Thomson? What is the name of the scientist? Full name is J.J. Thomson. Is it okay?
Yes,
J. J. Thomson. So, Krish, I come to you. What did Thomson propose? What did Thomson propose?
that an
Krish,
atom,
any inkling on it?
that an atom would still further be divided, and and then he sought to prove Dalton wrong.
No, see, Jonathan, that was not the purpose of J.J. Thomson that he was to prove his senior or his colleague wrong. So please don't read me wrong. That is not what the sense of study can be for any person. That I want to prove X, Y, Z wrong. It should be improvisation. So we wanted to improvise. And it was not Thomson's lookout what has Dalton proposed. It was the diaspora, the fraternity science did accept, and later they found more than what meets the eye. So they were of the opinion that, okay, at that time we did accept, but we need to improvise because there are few readings which are suggestive of improvisation. Correct, yeah?
So,
So that the part that you are speaking for and you are relating only to J.J. Thomson is uncharitable statement. Why I'm saying it is uncharitable statement? Because it is not to be wholly unilaterally to be on J.J. Thomson imposed. Who is then to take the blame or who is to be credited of the improvisation? You are to say the science fraternity. Is it okay?
okay, sir.
And then when it was thought over that yes, there are possibilities and we have read it beyond atom, then only did J.J. Thomson step in. Correct? Yeah. So
Okay, sir.
J.J. Thomson stepped in with his idea of what an atom can comprise of. Claudia?
Yes, sir.
Yes.
He proved Dalton wrong. He came with his idea of what an atom can comprise of. Am I clear, class?
Yes, sir.
And then, am I clear, Kunika, Gagan?
Yes,
Am
sir.
I audible?
Yeah, sir.
Okay. Kunika, please unmute yourself and answer. Kunika?
Yes, sir.
Okay, good enough. And then what he said was that atoms being akin to pudding. He said, J.J. Thomson, he said that atoms are akin to pudding, pudding in spherical shape. So atoms are spherical in shape. and it is akin to pudding. By that, what I mean, that positive charge in an atom is distributed. Positive charge in an atom is distributed with negative being scattered as dry fruits in pudding. Clear, dear?
Yes, sir.
Are you known to pudding? Have you seen pudding?
Yes, sir.
Yes, sir.
So pudding is, let's say, spherical, given a spherical shape, and then you're relating, drawing parallel of pudding with atom. And what I'm saying about shape, you are saying the shape of pudding is spherical. So is the shape of atom, and majority of pudding is other than dry fruits. So majority of atom being taken as positive charge and dry fruits being taken as the manner in which electrons or negative charge are distributed in an atom. So you are drawing a parallel of dry fruits with negative charge and the rest of pudding with positive charge. Is it okay?
Yes, sir.
Yes, sir.
As we know a phrase in English, proof of pudding lies in eating. Correct, yeah?
Yes, sir.
You know this phrase or not, dear? If you know, good. If you don't know, proof of pudding lies in eating. Clear, dear?
Yes, sir.
So either you say pudding, or if pudding is not known to you, watermelon is known to all of you. Correct, yeah?
Yes, sir.
Watermelon being known to all of you, so you can take a watermelon model as well and say that the red part of watermelon is positive charge of atom. Clear, yeah?
Yes, sir.
Is the red part to be taken akin to or taken manifestation of? Red part of watermelon is taken manifestation of positive charge in an atom. Clear, Krish?
Yes, sir.
And the seeds are studded here and there. You know that very well. In watermelon, you know, seeds are studded willy-nilly. Correct, yeah?
Yes, sir.
So those seeds are manifestation of negative charge in an atom. Clear, dear?
Yes, sir.
Yes, sir.
Either you are to go with pudding model or you are to go with watermelon model. They are same to us. This is what was proposed by J.J. Thomson. Clear, dear?
Yes,
Yes,
sir.
sir.
Okay. So as I said, the proof of pudding lies in eating. It did fail to impress scientists of that era. And why did it fail to interest scientists of that era? Being few observations which were not in alignment. There were few observations which were not in alignment with J.J. Thomson model. Is it okay? Few observation that you made. They were towing a different line. Is it clear, class? Few observation that you made were not possible an explanation for if I am to tow J.J. Thomson model. So if I were to throw J.J. Thomson model, then I was finding myself short of explaining few observation. Am I clear?
Yes, sir.
Yes, sir.
And what were they? What are the observation which we fail to explain? I'll come to them one after the other, but there were few observations which couldn't cut eyes with J.J. Thomson model. J.J. Thomson model failed those observations, could not get an answer to those observations. Clear, yeah?
Yes, sir.
And then was imperative on scientists of that era to go for a detailed study. Fine, class?
Yes,
Sir, I have a doubt, sir.
Yes, sir.
Scientists of that era to reject the process of figment of imagination and go for a detailed study. Why? Because what was proposed could not explain in toto few of the observations, few of the inferences from experimentations. Correct, yeah?
Okay, sir.
Okay, yes, Gagan, you're asking something.
So, how did you get to know that atoms can be still divided into electrons, protons, and neutrons?
They didn't get to know, dear. These were suppositions. Okay, Gagan, today we know. But when it was known to us that atom is indivisible, we had no inkling of it can be divided as well. Clear, dear?
Okay, sir.
Or it can subpart. We don't have subatomic particle. We didn't have any inkling. But scientists, as you know, scientist fraternity, they are always into experimentation. Claudia,
Yeah.
we don't know what is there, how to control coronavirus, but we are into experimentation. Correct, yeah?
Yes, sir.
So they are always into experimentation. They will not rest easy. Assuming that, okay, atoms cannot be divided, now we will rest easy. We rest all our concern because we are resting our case, atom will not be divided. Even if we are of the opinion that atom cannot be divided, we are in perpetual experimentation mode. Correct, dear? Not for proving our experimentation or our deduction wrong. That was not the motive. We were of the opinion that atom will not be divided, and we are good with it. We are very good with that. Okay, we were not protesting it. Nobody was contesting this at that time. And the purpose was not to contest it. The purpose was to keep experimenting. That is what science is all about, right, dear? Perpetual experimentation. So when they carried few experimentation, which I am not known to, you are not known to, nobody is known to, they were carrying few experimentation, and then it caught their attention that it is not possible for atom not to contain subatomic particles. It is not possible for atom not to be subdivided. And then when this got seeded in them, this, I will say, this doubt, which is good for mankind, scientists should doubt. So someone did so, and this doubt, when it got so, then they came up with few experimentation to rule out the possibility. It was not that they took it lying down. It was not that they got dissuaded. Yes, this is there. What to do now? Entire of our reading go on topsy-turvy. Now everything will go haywire, up, down. What shall we do? It is hell breaking loose. No, nothing of the kind. They thought, okay, yes, there are experimentation which are a departure, which are rank departure from what we thought of an atom. But let us then try to indulge, and after of indulging, we'll come up with if there is something more than what meets the eye, right, dear? So we were still into supposition. We were not sure of. It was just proposed that it can be a possibility. And that's the reason I said that proof of pudding lies in eating. And that's the reason we went overboard. Scientists of that era must not have taken it as duck takes to water. Why? Because they would have of the opinion, very dogmatic opinion, staunch, that atom cannot be divided. And they were of that opinion. But yes, there are different opinion and they should be respected. So someone came with an idea, okay, if it is so, let us prove it. Let us mathematically establish it. Let us experimentally establish it. And if it is getting established, I don't have any qualms. If it is not getting established, then we will indulge. And when we will indulge, then you will not call it overindulgence. Clear, yeah?
Yes, sir.
Okay. So Rutherford, what did he do? He took a metal, malleable metal. Malleable, you know, a property of metal. Is it known
Yes,
to
sir.
all of you?
Yes, sir.
Okay. And highest solubility will be gold. Correct,
Gold.
yeah? Gold is highest. So why? Because you can just keep on beating it. It will not break, it will not crack, right, Krish?
Yes, sir.
So what did he do? In order to get the reading cemented, I'm not saying that his purpose was to do something which was a departure from perception at that time. So I'm not being judgmental on it. What I'm trying to suggest is he was just trying to cement that yes, whatever we are into supposition is what the truth is, and that will get established by an experimentation. So his aim was to cement his position, to solidify his position. Is it okay, dear?
Yes, sir.
Yes, sir.
And for that, what he did, he took very thin gold foil. Am I clear?
Yes, sir.
Very thin gold foil. Who?
Four.
Rutherford.
Rutherford. Very thin gold foil, so thin that it is approximately wafer thin of the order 1000 atoms. Is it okay if you keep 1000 atoms side by side? Then the thickness that you will get is very small, is wafer thin, is much less than a wafer. So that thin gold foil he took. Find ya?
Yes, sir.
And then what he did, he took the gold foil, he did spread it, and after of spreading, he took helium nucleus. Is it okay? What did I say? He took nucleus of helium, or which is what we call alpha particle. Remember, what did I say?
Alpha particle.
Nucleus or alpha particle. Am I clear?
Yes,
Then
sir.
immediately you are to cross question. You know why? You know how I know you'll cross question? You'll cross question me asking that what do you mean by nucleus? We are of the opinion that atom cannot be divided. How can I take nucleus, right? Yeah?
Yes,
Yes.
Give me yes or no. Will you come with that or not?
sir.
So what will I tell in support to my logic, to buttress my point? What will I say? That opinion was already there in air. Okay? The opinion was very much there, already into existence. This opinion was either to be proved wrong or to get established. And that is what did Rutherford shoulder. Correct, yeah? He was there to experiment, either to get a support to what was in air. So hearsay were already on. Correct, yeah?
Yes, sir.
Hearsay were already on. And he was to either be in support of it or in opposition. So this was being done to either cement it or to dispense it. Clear, dear? To reject it, to reject with contempt. Clear, dear?
Yes,
Yes, sir.
sir.
What did he do? He took alpha particle. An alpha particle can be accelerated easily in lab. It's a particle which can easily be accelerated. So what he did, he accelerated alpha particle. An alpha particle, as I've told you, is nucleus of helium atom. That means from helium atom, what have you removed? You have removed the electrons. Clear, dear?
Yes, sir.
What have you done? Helium atom, you have removed the electrons.
Electron.
So they were removed. The negatively charged particles were removed. You are left with only the positively charged particle, and that is what was named nucleus. So what did he do? He took basically when he did take, he said, I'm taking alpha particles. Yes, now is known to you that alpha particle is nothing but nucleus of which atom?
Helium.
Helium atom. And why did he take alpha particle? Because mass of alpha particle is much higher than mass of proton. What is alpha particle? I'll draw for you. Alpha particle is 2 neutrons and 2 protons. Alpha particle means 2 neutrons and 2 protons. And when you are talking of helium atom, it comes with 2 electrons as well. Find here.
Yes, sir.
What you did? You remove the electrons, you got alpha particle, you got nucleus of helium atom, and as you can see for yourself, there are 2 protons and 2 neutrons. Of course, this will have mass more than that of proton. Correct? Yeah.
Yes, sir.
Universal mass of it. Universal mass of it is 4U. Is it okay?
Yes, sir.
What is the
Yes, sir.
universal mass of it?
For
4U.
you.
Am I clear? Class?
Yes, sir.
Yes, sir.
You can also write it as He 2 and 4. 2 the atomic number and 4 the mass number. Clear?
Yes, sir.
So what, sir?
Anyway, one up. Let's go in steps, baby steps. First things first. Now, what it did, he took gold foil. Correct? Yeah? Wafer
Yes.
thin gold foil. Fine.
Yes,
Yes,
sir.
sir.
And then what he tried to do, he tried to accelerate alpha particle. That means you can assume he tried to accelerate particle. Okay? And that particle had mass more than that of proton. That was known to him. Correct? Yeah?
Sir.
Yes, sir.
So what he thought that if these particles, alpha particle, hit electrons or hit protons, then they will get deflected, but the deflection will be meager. Why will the deflection be meager? Because mass is high. Yeah? So there are 2%, and there are 2 people, there are 2 persons, and one is of mass 1 kg, sorry, 10 kg, let's say, and the other is of mass 50 kg. Find here.
Yes, sir.
There are 2 persons, one of mass, there are 2 people, 2 persons, one of mass 10 kg, and the other of mass 50 kg. They collide. Who will get more deflected? 10 or 50?
And
Is it okay?
Yes,
Is
sir.
it okay? Tell me yes or no, dear.
Yes, sir.
Yes, sir.
Same perception. He thought that mass of alpha is much greater, alpha particle is much greater than that of proton particle. So if they collide, because it is scattered, the opinion was positive charge being scattered like red of watermelon. Correct? Yeah.
Yes, sir.
Yes.
So they will hit, and after of hitting, it will get deflected, but the deflection will be meager, very small on scale, fine whatsoever be, but it will get deflected. Fine, yeah, all of you are good with it?
Yes, sir.
Yes, sir.
And then he went ahead with his experimentation. To his surprise, he went ahead with his experimentation. To his surprise, majority of alpha particles, mind you, very important observations. To his surprise, majority of alpha particle just crossed the foil undeterred, without getting unscathed, unblemished. Is it okay? Majority of alpha particle, they to the same line in which they were accelerated. Clear, dear?
Yes,
yes,
sir.
sir.
They toward the same line in which they were accelerated. So they came out of the golden foil or gold foil undeterred, unscathed, unblemished. Nothing, not a thing happened to them. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
And a few of them, as per his perception, did get deflected, and they got deflected by small amount as well. So that was much in consonance with what he thought. Second observation was much in commensurate with his thought process. It was just opposed with his thought process, I'll say. But first one wasn't. Why? Because he thought that positive charge is all over the atom. Correct, yeah?
Yes, sir.
Yes, sir.
And that now you are to debunk. That was rebuked. Can we say that? That was rebuked. That was ought to be rebuked. Tell me why. Because were it distributed through and through as red or watermelon, then every alpha particle must have got deflected, must have got some or the other change associated after of encountering golden foil. Agreed or not?
Yes, sir.
Yes, sir.
Yes, sir.
That didn't happen. That was not the observation. It was a rank departure. And the best is yet to come. The best is yet to come, which was a root shock. What was root shock? The root shock being 1 in every 12,000. What did I say? 1 in every 12,000 got deflected. And deflected by you know what angle? Anyone? 1 in every 12,000 alpha particle, 1 in every 12,000 of alpha particle got deflected. And got deflected, you know by what angle?
180.
By 180 degree. Got deflected by 180 degree. This was a shot from blue. This, you are completely off guard. You are caught off guard. Because nobody thought that there will be a deflection of 180 degree. So much so that it was such a surprise to them that a knee-jerk statement is that it is similar to someone throwing stone to a sheet of paper and that stone getting reflected to him. He being hit by that stone. He took it that way. What did you have?
Yes, sir.
So this was a complete surprise. And what was the ramification? The ramification, of course, being there being changes in coming. And what were they? First things first. If you ask a child to throw a stone on a wall, right? Yeah? Give him 10 pebbles. Okay. Blindfold him or her and ask him to throw stones to a wall. Correct? Yeah?
Yes, sir.
Will you be able to make that the stones are striking the walls or not? You will say yes. Why? He'll be able to hear sound, the thud of stone hitting the wall. Correct? Yeah? Say me yes or no?
Yes, sir.
Yes, sir.
Okay. You are blindfolded, fine, but ears are operational, so he'll be able to hear thud of stone on the wall. He will say that, okay, stones are hitting the wall. Correct, yeah?
Yes, sir.
Or wall being hit by stones. Fine, yeah? Say me yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Take the same child to a barbed fence. Instead of wall, take him to a barbed fence. Is it okay? Barbed fence, you know?
Yes.
So what is bar wiring? Wiring by bar. Bar wiring is known to you or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, and then ask him to do the same. So he throws stones. Will he be able to hear for every stone that he throws a third? Will he
No,
be
sir.
able to hear for every stone that he throws a third? Yes or no?
No,
No,
sir.
sir.
No. And what then he will think of? What perception he is to generate? He is to generate a perception that there is no wall in front of him, correct? Yeah. Or he is to generate a perception that there is an open area in front of him, agreed or not?
Yes, sir.
Open area with a stray here and there particles present. Can we say that?
Yes, sir.
Certainly, he is not to say that there is wall anymore in front of him. Say me yes or no.
sir.
Yes, sir.
Yes.
What did he say? Yes, there are particles, but they are scattered. They are sporadic. Correct, dear? Can we say that?
Yes,
Yes, sir.
There are particles, but they are sporadic. Spasmodic. They are scattered. Right, dear? They are scattered. And majority is free area to him. Correct, dear?
yes, sir.
Yes,
Yes,
sir.
sir.
Majority is free area to him. Only then he can justify a stone toeing the line in which it was thrown. Correct, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the same was accepted by science fraternity of that era. They said that it is not that positive charge is present through and through as the pudding or watermelon model. Clear? Yeah?
Yes, sir.
Yes, sir.
So what did they say? No, majority of atom is free space. Clear? Yeah?
Yes, sir.
Majority of atom is free space. And this we got from what analogy? This we got from barbed fence analogy. Correct? Yeah? Correct, guys?
Yes, sir.
Yes,
This
sir.
we got from which analogy? Barbed
Barbed
fence stone
fence.
was thrown, right, dear? So which analogy did help us to come to this conclusion? Come on, tell me, dear.
After.
Barbed fence.
Bob
Yes.
fence.
So we got to say that yes, majority of atom is free to us. So majority is free. Why? Because majority of alpha particle did go through the golden foil undeterred. Correct, yeah?
Yes,
Yes,
sir.
sir.
Okay. And there is a spot. There is a spot. And that spot is where mass of atom is concentrated. That spot is where mass of atom is concentrated. Now, this from where we did generate? Tell me, this idea ideating from where did this idea stem? You will say this idea stems from the fact that 1 out of 12,000 got deflected and deflected by what angle? By
180 degree.
180 degrees. Correct?
Yes, sir.
Yes, sir.
Deflect helium nucleus is not an easy ask. Why? Because helium nucleus itself is good on mass. Right here?
Yes, sir.
Yes, sir.
We came to conclusion that if helium atom was deflected and that too by 180 degree, it must ask for good mass. It calls for good mass collision. Correct? Yeah.
Yes, sir.
So that good mass is only to show 1 in 10,000. Therefore, majority of mass of atom is located at a particular point, right here.
Yes, sir.
And if so, that majority or that point is now given a name. It is called nucleus. Fine.
Yes, sir.
Yes, sir.
Tell me all of you.
Yes, sir.
It is called. Tell me all of
Nu-
you. What is it called?
Nucleus.
nucleus.
Called nucleus. And till the time of Rutherford, we were of the opinion that nucleus means positive charge. Clear, dear? What does
Yes, sir.
nucleus mean? What does
Positive
nucleus mean? Tell me,
charge.
dear. Till that time, till the
Positive
time of
charge.
Rutherford. What does
Positive
nucleus
charge.
mean? What did nucleus translate to? Nucleus translated to positive charge.
Positive charge.
Clear?
Yes, sir.
Later, Chadwick did come to conclusion that there are particles other than neutrons and protons. Sorry, protons and electrons, and they are neutrons. Clear? Dear? Chadwick
Yes,
did
sir.
come with experimentation and his own deductions. And his own deductions being there are particles other than positively charged protons and negatively charged electrons. Positively charged were known as protons and negatively charged were known as electrons. Right? Yeah. Negatively
Yes, sir.
charged were known as electrons. Correct? Yeah.
Yes, sir.
Yes, sir.
And Chadwick came to conclusion that there are particles other than protons and electrons. Fine. There are particles other than protons and electrons, and they were given name. What are they called? Neutrons. Clear here?
Yes,
Yes,
sir.
sir.
What are they called? Neutrons. So, nucleus, nucleus, to which we associate major mass. Nucleus, to which is associated mass of an atom, comprises of, tell me class, comprises of
Protons and
neutrons
neutrons.
and protons. Clear here? Comprises of neutrons and protons.
Proton.
Protons.
3 classes ago, I told you that they are collectively called
Nucleon.
Nucleons.
nucleons. Correct, yeah. So neutrons and protons. Neutrons and protons are collectively called nucleons.
Nucleons.
Clear, yeah?
Yes, sir.
Yes, sir.
Okay. And and majority, or you can go to the extent of saying mass of an atom is equal to mass of nucleons. Clear, yeah?
Yes,
Yes,
sir.
sir.
Okay. So mass number. We define mass number. You know what is mass number of an atom? Mass number of an atom is collective mass of neutron and proton. Clear, yeah?
Yes, sir.
Collective mass of neutron and proton is given a name. And what is it called? It is called mass number. Clear?
So,
Yes, sir.
What about atomic number? Atomic number in general is half of mass number. Why so? Because atomic number relates to number of protons. Clear? Is it okay, dear? Atomic number relates to number of, tell me, dear.
Protons.
And mass number?
protons and
Number of protons and neutrons.
Very good. Got, dear, the difference between atomic number and mass number?
Yes, sir.
Yes,
Okay,
sir.
so if I write He24, what do you understand of this symbol? What do you understand of this symbol? He is for helium, of course. What are the 2 and what are the numbers doing here? 2 and 4. What are these numbers to indicate? Anyone?
2 is the atomic number and 4 is the mass number.
2 is the atomic number and 4 the mass number, right? Yeah?
yes, sir. Sir, the atom. So, sir, like in a
Yeah.
neutral atom, the atomic number can be equal to the number of electrons, also, right? So,
Yes, yes, of course, of course.
but
That
if
is good. Yes, Krish.
but if
Of
we
course,
don't, but
not
if
in iron.
yes, sir, if we take an ion,
No, then it will not be. You can take alpha particle, He2 plus, right? Yeah. In 2
yes,
plus, there is no electron. Are you getting it?
yes, sir.
So what will you say? How can you say that it is equal to electron? There is no electron in it. There is no electron to be seen, correct? Yeah.
Yes, sir. So,
So
like,
it is better to relate with number of proton than electron, because electrons can be dislodged. Not proton, but electrons can be dislodged, correct? Yeah.
yes, sir.
So we related more to number of proton, but you are absolutely right in what you have said. If you're talking about a neutral atom, then you can also call it to be number of electrons. Correct, yeah?
Yes, sir.
Okay. So this is atomic number and the other one is mass number, right? Yeah.
Yes, sir.
What is the difference to get you? What is the difference to get you?
Number
4
of
minus 2 over here, 2. What is 2 indicative of?
number of protons.
Atomic number.
Atomic
No, 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 no. That is okay. 2 you got, 4 you got. I'm asking for what is 4 minus 2 indicative of? What does this indicate? Number of what?
Protons.
Number of protons. Right here? It indicates number of protons. Correct here? Now
Yes,
tell
sir.
me, if I write H11, what you get to know?
Has
Hydrogen 11 I write. Then what you get to know? How many proton, how many neutron, and how many electron? I am coming to precious question. How many proton, how many neutron, and how many electron? Tell me, dear. 1H1. What will you say now? 1H1. Getting it, dear? What is this to you? What is this to you? 1H1. It says that there is one proton, correct? It says that there is one proton. First, I am starting with this one. So it says that there is one proton for sure, correct? Yeah.
yes, sir.
Yes, sir.
And this you know is number of nucleons, correct? What is
Yes, sir.
4? 4 means what to you just now you have said. This is number of neutron and proton, correct? Yeah. Neutron plus proton, correct?
Yes, sir.
So can we say this number of nucleons? Krishan Kunika, please
Yes,
respond.
yes,
And
sir.
we say
Yes,
this
sir.
number of nucleons.
Yes, sir.
Yes, sir.
Over here, number of proton is equal to number of nucleons, correct?
Yes, sir.
Yes, sir.
And if number of proton is equal to number of nucleons, then how many number of neutrons you are to get?
Zero.
0.
Oh, good, Krish. So this is indicative of hydrogen nucleus. How can I say so? One proton, that's it. No neutron. Clear? One proton, that's it. No neutron. And no electron. Clear, dear?
Yes, sir.
Yes, sir.
What is 1H1 to indicate? 1H1 will indicate hydrogen nucleus. Can we say that? Hydrogen atom nucleus? Because hydrogen atom nucleus has got no proton, sorry, no neutron. Clear, dear?
Yes, sir.
Hydrogen atom nucleus has got no neutron. Clear, dear?
Yes, sir.
So
Yes,
what
sir.
is this to you? One proton and one nucleon. One nucleon means zero neutron. Clear, class?
Sir.
Yes,
Yes,
sir.
sir.
Now I write 1H2. Tell me, what is this? How many neutron, proton, and electron? Tell me, dear.
Sir.
How many protons? Quickly, come on now. How many protons?
1,
1,
One,
One. And how many nucleons?
2,
2,
two,
So how many neutrons?
1,
one,
One. Good. 1H3. Tell me.
2
Tell me
neutrons, 1
quickly.
proton,
proton.
One proton,
2 neutron.
2 neutrons.
two neutrons. Right here. In all three, all of them. Please look at them. This is one, this also one, this also one. Correct here?
Yes,
yes,
sir.
sir.
So what do we get to see? We get to see that number of proton in all being one, but number of neutron being different, correct?
Yes, sir.
Yes,
Yes,
sir.
One
sir.
one proton, but number of neutron being different. Clear, dear?
Yes, sir.
Number of neutron is different, then their mass number will also be different. You know that very well, correct, dear?
Yes, sir.
Yes, sir.
So atoms having same atomic number but different mass number. What did I say? Atoms having, repeat it please. Atoms having same
atomic
Same
number, atomic
atomic
number,
number, but different
mass
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 number,
number.
number are called, anyone,
Isotopes.
isotopes.
are called isotopes. Is it okay? So now you know what can be isotopes of carbon. Carbon can have C12 or C14. Correct? Yeah. What are
Yes.
the isotopes of carbon? What are the isotopes of carbon? Come on, dear. C6 will be the
C12.
atomic number, but 12 or 14 can be the mass number. Correct?
Yes, sir.
So mass number differ in number of neutrons. Correct? Yeah.
Yes,
Yes, sir.
sir.
So you can say that they are C12 and C14. They are isotopes of carbon. Can I say that?
Yes, sir.
Yes, sir.
They are isotopes of carbon. Clear, dear?
Yes, sir.
Clear,
Yes,
all of
sir.
you? A lot being bombarded today. Clear or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. They are called isotopes. Good. Good enough. Now I repeat what we did the other day. Now I repeat what we did the other day, and that is valency. Valency, as you know, is the number of electrons present in outer shell. Is it okay? What is valency? Number of electrons present in outer shell. Am I clear?
Sir, I had a doubt, sir.
Yeah, yeah.
Sir, you said the maximum number of electrons in one cell is 2n square, right, sir?
Yeah, 2n square. It can maximum accommodate. I didn't say
Sir,
it will
but
be there. I said maximum that it can accommodate will be 2n square. Yeah, please continue.
we take 288, no, sir. Why?
Yeah, because 8 when we take here, 8 is the octet state. It is called octet state. And by octet, what I mean inert state. So when you write the postulate 2n square, then after of 2n square, there is another statement which says that the outer shell always tries to attain octet state. Is it okay?
Yes,
The
sir.
outer shell of any atom has always an inkling to attain octet state. Why? Because if it attains octet state, then it will be in inert state. Activity will reduce to a naught. Clear, dear? So that
Yes,
is
sir.
what it tries to. Therefore, outer shell will always try to be in octet state. It may be able to hold more than 8. Correct, Gagan?
Yes, sir.
But it will try to be in what state? Octet state. Clear? 2n
Yes,
square is the capacity to hold. It doesn't mean that it will hold that amount. Even if it gets less than that and it is able to attain 8, outermost is 8, it will rest its case. Is it okay? It will not go beyond it. Fine,
okay,
dear?
sir. Yes, sir.
Okay. So sodium, when we say Na11, what do we get? 2,
2.
8, and 1. Correct?
Yes, sir.
So 2, 8, and 1. All of you, please now. 2, 8, and 1. How many electrons are there in the valence shell, which we
1.
also call energy level? Energy level, what will you say?
1 electron.
1 electron. So what will be valency of sodium atom? 1. Is it okay? What will be valency of sodium atom? Tell me, all of you.
1.
1. Now I take chlorine. Chlorine is 17. Correct, dear? So we will
Yes, sir.
get 287. Correct?
Yes, sir.
How many electrons in the valence shell? Fresh
7.
7. So instead of giving away with 7 electron, instead of letting go 7 electrons, what will it try to do? It will try to get 1 electron. Clear, dear? We have seen this the other day. It will try to get 1 electron to complete it octet state. Say yes or no? So we will not call valency as 7 here. We'll call valency as 8 minus 7. Find here. again the valency will be 1. So be it chlorine or sodium, valency is 1. Yes, we get to know whether it will donate or accept by the denomination of charge. Is it okay? If it is willing to get out, do away with, then we write plus. And if it has got inkling to accept, if it is not willing to do away, but is to accept, if it is the recipient, then it will be marked as minus. Fine, dear?
Plus chlorine.
Okay.
Chlorine. Yes, sir.
Plus in which case, when it is willing to do away with. And minus in which case, when it is not willing to do away, but is willing to accept. Clear, dear?
Yes, sir.
Yes, sir.
That will be minus to us.
Sir,
Fine. That is balancing. Yes, Tunika?
yeah, so in the chlorine atom, because
Yeah.
it requires one chlorine and one minus, right?
Yes. Exactly. We generally take it halfway, Gunika. Metals generally you will get with plus because they are willing to do away with, and non-metals are to come with minus generally. Okay, no blanket perception here. Fine, yeah? Clear, Gunika?
Yes, sir.
Uh, So this being about isotopes, valency, and there is one more term which you need to know about, that being isobars. Can anyone tell me what are isobars? Anyone tell me what are isobars? One, different elements having different atomic numbers, of course, but same mass numbers. Is it okay? What did I say? Different elements having different atomic numbers. Of course, it goes without saying different elements, so different atomic numbers, but same, but
Mass
same,
number.
but same, Gagan, repeat, but same mass
Mass
number.
number.
Idea? Different
Yes, sir.
atomic numbers, but same mass number. Different atomic numbers, but same mass number. What is it called?
Isobars.
Isobar. Find ya?
Yes,
So,
sir.
Yes, Gresh.
so isotopes are the same element and isobars are different elements.
Yes. Because isotopes element are to be same, Krish, till the time atomic number is same. Correct? Yeah.
Yes, sir.
Yes, sir.
Okay. So there we are talking of same element, but exhibiting in different forms. And here we are talking of different elements, but showing same mass number. Clear? Fine, Krish?
Yes, sir.
Okay. Fine, all of you?
Yes, sir.
Yes, sir.
Okay, I'll keep to this today, dear. Revise the portion very well. Fine.
Yes,
Yes,
sir.
sir.
Okay, thank you, class.
Thank you,
Thank you,
sir.
sir. Bye, sir.
Bye, dear.